Very pleased to have David Dunning from GAMA, the General Aviation Manufacturers Association, speak. GAMA has really been key. So we started having our activities in 2013, had our first TVF workshop in 2014, and GAMA started their EPIC committee in 2015, right? So they were really visionary in seeing all these different developments and how to get them certified. And if you're an eVTOL developer and you're not, or an aircraft developer and you're not a member of GAMA, or a helicopter manufacturer and you're not a member of GAMA, then kind of shame on you. But you don't get to complain when you don't like the regulations that come out. GAMA's role is to be an interface between the companies and the regulators around the world. And they really do yeoman's work, and it's really great to work with not only GAMA as an organization, but Dave Dunning specifically. He's been, I'll say, tireless, but maybe that's not the right word. He's been a stalwart leader for the activities. So David is the Director of Global Innovation and Policy at GAMA, where his work includes overseeing GAMA's Electric Propulsion and Innovation Committee, EPIC, and an advanced air mobility portfolio. David began his aviation career in the U.S. Air Force and has held leadership roles in military, civil, and government aviation. Before joining GAMA, he served as the FAA's AAM program manager. David?
All right, thanks, Mike, and appreciate the plug. I'll reemphasize, shame on anyone for not being a member of GAMA. Well said, Mike. So, good morning. It's great to be here with such an all-star lineup of speakers that are soon to follow. As Mike said, my name is David Dunning. I'm the Director of Global Innovation and Policy at the General Aviation Manufacturers Association, or GAMA. We're going to talk about rules this morning. And I know that's not the first thing that might come to mind when you think about the exciting potential for advanced air mobility. But just a few years ago, we were really operating in a world of uncertainty. And just as an illustration of this, I imagine we have a handful of pilots in the room. So if, don't be shy, but if you're an airplane or helicopter pilot, raise your hand. Actually got quite a few, so that's excellent. All right, so keep your hands up. And keep your hand up if you're a powered lift pilot. And they all went down. So, and that's a phenomenon, that right there just says it all. So, generally speaking, there really aren't that many pilots in the country. And then generally speaking, there are virtually no powered lift pilots. So there's a fascinating story here if you put yourself in the position of the manufacturer. There was no clear framework for certifying powered lift pilots, training them effectively, or setting the operational rules for eVTOLs. And as you can imagine, that's been one of the steepest mountains we've had to climb as an industry. So fast forward to today, and thanks to significant collaboration between industry and the FAA, we have a special federal aviation regulation, or an SFAR, that provides clarity on pilot certification, operating rules and training, as well as an updated engineering brief on Vertiport infrastructure. So these milestones are a huge step forward for advanced air mobility, and we're going to reflect on that journey, celebrate the progress, and look forward to what's next. So each of the speakers today, they've all played an instrumental role in shaping this landscape, and they'll be sharing their perspectives on how we got here, the challenges that still remain, and how we continue to build towards a seamless regulatory framework for the future of advanced air mobility. Our first speaker is Kristen Costello. She is the Government Affairs Lead at Beta Technology. Kristen brings a unique perspective to this conversation. Not only does she lead Beta's regulatory engagement, but she's also an accomplished pilot herself. And prior to Beta, she worked as executive management for a UAS company, held a management position at a Part 135 operation, and acted as a corporate pilot in Part 91 and 135 operations flying Cessna Citation aircraft. Kristen began her aviation career working as a flight instructor and check airman at Kansas State University's Salinas Part 141 Flight School. So with that, I'm going to pass it to Kristen Costello from Beta. Kristen, come on up.
Today, we have an interesting session, and I'm excited about how we decided to structure this out. So first, I'm going to talk a little bit about the pilot certification part of the SFAR, and then get into the beta-specific path. And what's unique about the three people, myself, Ryan, and Tom, is the differences in our company's approach. You're going to get to kind of see different facets of how the rule is going to apply. So I'm going to start kind of from the dual seat perspective, and talking about the pilot certification pathway from a holistic standard there, or perspective. And then Ryan will get a little bit more into single seat considerations, FSTDs, and his company. And then from Tom, we get to kind of look ahead. So I say that just as we're kind of looking, if you feel like, well, hey, we're not touching on this, it may be coming. So just to kind of give that little forward look. So, fun little graphic here. With the SFAR, as manufacturers, we're all pushing towards certification and entry into service, for eVTOL aircraft. And powered lift really came out as the predominant type. We're faced with the unique challenge of being the manufacturer and certifying these vehicles while the regulatory environment is being formed. So the FAA identified that in order to operationalize these vehicles and integrate into the NAS, there was going to be this framework needed for the operational rules and the pilot certification pathways. And I do want to take a minute just to recognize the FAA for this effort. And you'll hear this across industry. I think we cannot say enough about the amount of work that went into this and in the time frame in which they did it. So when you consider that the NPRM was put out in June of 2023 and we had a final rule by October of 2024, that was 880 pages, and a lot of content to really integrate these vehicles. It was a monumental lift, and again, the outcome has enabled operations. The agency will revisit the SFAR, using data from these initial operations for future rulemaking. So it really is a great approach that they chose. So I apologize if you were in my presentation on Tuesday and you've already seen this slide, but you get to see it again. So, this is, again, the SFAR was chosen because of the immediate need and the temporary nature. It kind of gives that ability for the FAA to be agile while they're still gathering this data and take the learnings and apply those to future rulemaking efforts. So again, 880 pages of regulation, and we've had it for just a little over 3 months now. That's a lot to interpret and digest for us as companies, and we're still working through it. So I say that, GAMA, David, they've been amazing, VAI, other organizations, in helping industry kind of come together and figure out how this fits with what we're trying to do. So, I think another key message is that, I was on a panel with some folks from the FAA last fall, and, a pride point was that it does enable the operations from day one without the need of exemptions. So that plus the future proofing built in that I believe our speakers will be getting into a little bit more later. So airman certification from kind of a high-level view here. So the SFAR provides a path for initial cadre from the FAA and company test pilots to instructor pilots to line pilots. The FAA did not establish classes within the powered lift category because powered lift have many different configurations, unique inceptors, diversified flight controls, and distinctive operating characteristics. Because of the diversity of design between these aircraft, the FAA also imposed a type rating requirement. So this ensures candidates will receive the adequate training and are tested on the unique design and operating characteristics of that aircraft. The SFAR did retain the powered lift category, citing that it is a key element of airman certification for ensuring persons exercising the privileges of their pilot certificate possess a common level of competency. So I'm just going to briefly touch on this. And again, this is something that I believe we'll talk about a little bit later. But in addition to the traditional dual controls pathway, 3 alternate pathways were created to certificate powered lift pilots using a single set of flight controls and a single pilot station. So the first pathway is the single set of controls that's accessible by both instructor and applicant. The second has expanded use of flight simulators. And then that third is, again, that little bit of future proofing with deviation authority. The powered lift SFAR also does account for experience, providing a degree of relief from certain FAA requirements. However, it did have some other requirements to ensure that the appropriate mitigations were in place through applicant experience and structured training environments. So, looking at the aeronautical experience piece, applicants must already hold at least a commercial pilot certificate with at least an airplane category and single engine or multi-engine class rating, or a rotorcraft category and helicopter class rating, and the corresponding instrument rating. Applicants also using the pathways in the SFAR do so in accordance with a approved training program, again, to further de-risk with Part 135, 141, or 142. And then there's a PIC reduction to 35 hours that can be claimed from the 50-hour PIC requirement, as long as that training, again, is conducted under one of those approved training programs. To touch a little further on the experience part and what might be interesting for this crowd, the ACS for rotary wing pathway has a different set of standards than what you would see for fixed wing pathway. So if you come from a fixed wing pathway, there are certain things that you don't have to do in the powered lift ACS. The same is true for the rotary wing pathway. So the rotary wing ACS accounts for those things, and there's quite literally different elements on the check ride based on the license that you came in with. And this also means that the syllabus then needs to be flexible based on the airman that is going through the training. So because of our platform at Beta, we have a little bit of flexibility with the in-aircraft training, and we also have a tailored syllabus for a lowered risk training profile. So to get a little bit into Beta's training path, so again, and I think this is something to kind of note as you see the progression of speakers today. So looking at Beta and how we're doing it, looking at Joby, and then Wisk. Again, it's very unique and really interesting to see how this has all kind of come to fruition. Beta does have a dual seat configured aircraft, and because of that, our training path was pretty much unchanged from what we were originally planning as a result of the final rule. So our training pathway enables traditional Part 61 training with no need for an alternate pathway. So those 3 pathways that we discussed earlier, we will not be having to take any of those. We do have the ability to take the 35-hour PIC reduction if we choose to do a 141, 142, or 135 approved training program. And then again, we do get to kind of have some more flexibility with how we approach simulation. So we don't have a requirement for an FFS with this dual control pathway, which allows us to have a cost-effective FTD where we can credit about 15 hours of time. And you can see there that that kind of details out what some flexible hour options would be based on how we want to structure the training. So all applicants are required to have 50 hours in category. And with us, we have the option to do all 50 hours in aircraft. We could do a 142 with an FTD, claiming 35 hours in the aircraft. And then if we did choose to do the FFS option, that then reduces the time in aircraft down to about 20 hours. And then another part of this is that to claim some of the alternate pathways, you must simultaneously seek category type and instrument rating. And for a dual control pathway, you have the option to do that, but it's not a requirement. So again, talking a little bit more on the simulation side, which we talked about there. We've developed and we're utilizing simulators at kind of all stages of development, and we've done this already to train FAA, Air Force, and customers that have flown our aircraft. And so the simulator also helped with that qual-eval process. Again, our dual control aircraft don't require us to have a full flight simulator to clear pilots to that solo phase, but allows Beta to qualify and use flight training devices, keeping our operational costs low. And because of the flexibility that our design provides, and the publication of the SFAR, we now have the decisions to kind of tailor this to see what best fits our customers' needs. So I'll kind of end with this, and this is an interesting and probably unique approach that Beta has because of the commonality in our system. And if you were at my talk on Tuesday, you saw where I stepped through our approach to certification. So if you weren't, just to recap real quick, we're certifying our electric engine first under Part 33. Then we're certifying our CTOL, our conventional takeoff and land model, Part 23, which is the airplane there on the top, CX-300. And then we are basically going into our VTOL, which is the A250. So it's a stepwise approach to certification. And, really that strategic commonality in design. So when you look at the CTOL and the VTOL, they have roughly 75% commonality in systems. And that commonality in design also is uniquely advantageous in the training environment as well. So for the CTOL, the training process is remarkably similar to any instruction a 135 operator would have in obtaining a new aircraft. And since it is certified under Part 23, really all you need is a high performance endorsement. Pilots with a commercial license would really only need a week-long training course and a check ride, or a checkout. So going into the VTOL approach, having that foundational knowledge of the CTOL kind of then takes you straight into what is necessary to then have the training for the VTOL. So the lift plus cruise design enables us to go vertical flight mode to wing-borne operations. So the first three stages of our syllabus for the ALIA training family are completely common between the two aircraft variants. So again, following that fundamental proficiency in the CTOL knowledge, you then step into the VTOL syllabus expansion, and you can use the aforementioned FTD simulation credit as needed. So that kind of is a very quick overview of high-level pilot certification from the SFAR and then Beta's approach to how we plan to tackle this. But I think the main point, again, is that we've had this rule for 3 months, and we're still very much in talks with the FAA and figuring out how to operationalize it. And thus far, those conversations have been really great and productive, and also, again, with the aid of our industry trade associations. So with that, I'll open it up.
Within the what you showed there was the instrument ratings, and I'm wondering if the aircraft is not entering the market initially with IFR certification, is that something that can be deferred in terms of the pilot training, or is that a prerequisite where they have to have instrument training, either a fixed wing or rotary wing, prior to getting into the pipeline? So the three simultaneous ratings are applicable whether or not the aircraft will be certified for IFR.
Great foundation set there related to, all right, how are we going to certificate powered lift pilots? So for those of you that had your hands up earlier that were airplane or helicopter pilots, if you are commercial and instrument rated, as Kristen just outlined, the SFAR provides a pathway for you to be able to undertake a tailored training curriculum from one of the manufacturers and achieve your powered lift category certificate as well. So the next question is, okay, what about single pilot, single station aircraft? And next up, we have Ryan Naru, a longtime leader in the AAM industry who has been part of this ecosystem really since its inception. Ryan is a leading voice across many AAM forums, and he's played a really pivotal role in helping Joby establish itself as a trusted partner in navigating these regulatory conversations. Ryan is the Aviation Policy and Regulatory Affairs Lead at Joby Aviation. His primary focus is on aviation safety, rulemaking, and policy development. And before joining Joby, Ryan worked at Uber Technologies on the Elevate project. So really been around eVTOL since day one. He began his career first as an aircraft mechanic and aspires to earn his PPL. So please give a warm welcome to Ryan Naru.
Well, thank you, David, for the very kind words. And Kristen, thank you so much for the great intro as we kind of move through the many flavors of pilot qualification in powered lift aircraft. One thing I also want to reflect on as well that Kristen mentioned is just want to express a message of support for all of the federal workforce right now. We are extremely grateful for what they do. There is no world that we get into service without them. And just wanted to send a personal note to any of the federal workforce that are here or that will be seeing this later. Thank you for your service. All right, there we go. So just wanted to do a quick review and refresher. I know many of you who are familiar with Joby are familiar that we are pursuing a flight control interface that's known as unified flight controls. And unified flight controls is essentially a type of human-machine interface that has about a 30-year heritage at this point. It started because the UK, the Royal Air Force, was having, and the Royal Navy in particular, trouble with their Sea Harrier program. While that aircraft provided a lot of capability, it also came with a very high training burden and a lot of pilot cognitive errors. And so moving forward into the next generation of VTOL tactical fighters, worldwide, NATO wanted to have a more augmented flight control system for these aircraft to simplify the workload, to reduce pilot cognitive errors. And what happened was we had Kinetic run the VOC Harrier program, which was the first time that unified flight controls were pioneered. It was part of a set of experiments that tried several different types of flight control interfaces, and unified was the one that was chosen and selected both by the UK and the United States to move forward into the X-35 program and then into the F-35B. The Joby aircraft uses the same flight controls as the F-35B minus rudder pedals. So we actually are using a twist in the right-hand inceptor in order to perform yawing maneuvers with the aircraft, either as a pedal turn, for example, in the hover environment, or to introduce a little bit of crosswind compensation if we're making an approach to a runway. A couple of really key elements to unified is that height control is always on the right side, speed control is always on the left side. The axes are all independent of each other. So this means that, for example, if you're going to increase your airspeed, you're not going to see a corresponding change in pitch with the aircraft, right? This is, while it's very, very, very airplane adjacent, it is not as complicated as flying an airplane. This is what's known as simplified flight controls or highly augmented flight controls. The other thing, too, that underpins this aircraft is because it's a full authority, full-time, fly-by-wire system, the aircraft also is able to have lots of flight envelope protections, which means that, for example, we can limit angle of attack. We can resist overspeed. We'll have limiters on bank angle and pitch attitude. We'll have limiters, for example, on the vertical descent rates. We'll reduce or prohibit combinations of height and forward speed that would, for example, create risk related to vortex ring state. So the aircraft has lots of augmentation, which makes it very, very, very simple to fly. So how does one become a pilot of the Joby aircraft? The pathway that we're defining right now begins with fixed wing experience. In fact, while the Joby aircraft has multiple propulsive units, we believe that an airplane single engine land rating is actually all you would need as an incoming pilot. You would need obviously your airplane instrument rating, and it would need to be at a commercial pilot level. And you would need to also have a minimum of 500 hours as well as passing some aptitude tests before we would let you into the Joby training program. A little bit of an illustration of what it would look like. Joby is standing up a Part 141 flight school. We just announced that we had received the certificate for that flight school. It's being stood up in Watsonville, California, which is the neighbor airport to Marina, which is where we're doing flight test and manufacturing of the aircraft today. It's in the Monterey Bay. It's a beautiful place. It's a beautiful place to fly aircraft, to learn to fly aircraft. And essentially what we're looking to do is give people a career pathway all the way from 0 hours to the Joby aircraft, where they can become private pilots, they'll get their instrument rating, they'll become commercial pilots at 250 hours, CFIs, working within the program itself and being mentors for other pilots who are beginning the training program, and then essentially a really tailored, essentially urban air mobility transition course from 200 to 500 hours. And then we'll be really focusing on competency-based training. While that's not part of the FAA's pilot qualification framework, within Joby, that's going to be really make sure that we are developing the right kinds of pilots for our operation. So let's talk for a second about the airplane prerequisite for the Joby aircraft. Our team's direct experience over 10 years, both with the VA carrier, with the X-35, F-35B, is that airplane pilots using unified flight controls have a much easier time approaching those flight controls. It is much easier to teach an airplane pilot how to slow down into a hover than it is to take a rotorcraft pilot who has the motor skills related to operating a helicopter and retrain them for a different set of motor skills which are very airplane adjacent. To give you an example of what that means, the aircraft on the right-hand inceptor, we were talking about how it's just like an airplane. If I pull back on the right hand, the aircraft goes up. If I push forward, the aircraft goes down. But if I was to have the motor skills of a helicopter pilot, if I'm pulling back on the cyclic, right, I'm going to start going backwards. If I push forward, I'm going to go forwards. So that's the kind of essentially reversion to type that we want to be sure that we're training out of our pilots if they do have helicopter ratings or helicopter recency. We are not precluding helicopter pilots from joining the Joby cadre of pilots. However, we were going to be putting very special emphasis on their transition. We're going to treat them somewhat differently than we would the incoming airplane pilot. Well, there you go. We're not excluding rotorcraft pilots. More study is necessary to quantify the required exposure to become fluent in the unified hover environment if you're coming from the rotorcraft background. One other note here too, the buff box right there. So if we're talking about a Joby pilot who's going through the 141 school, who's an airplane pilot from the very beginning, those pilots will experience a hover for the very first time in the S4 training environment. We will not be sending airplane pilots to go learn how to hover in a helicopter before they learn how to hover in a Joby. So, at a high level, Joby's pilot training program consists of 5 main parts. It is a very big catalog of training materials and manuals, not just for the trainees, but for the instructors as well. So we have an instructor training program where we're constantly cross-checking our ability to provide good instruction. We're using, excuse me, flight simulation training devices, in particular level 7 and level C devices. These are the same kinds of devices that are used today for large transport helicopters that are used by the airlines to type rate their pilots for large transport jets. Solo flights is going to be a really big part of the Joby training program as well. We'll have competency checks along the way, and of course, the final check ride. Now that the FAA has required a type rating for all powered lift aircraft, that check ride is going to be essentially the culmination of the Joby manufacturer's required training program, the category rating, the instrument rating, the powered lift type rating for the Joby aircraft. Now, one of the things to reflect on for a minute is, as Kristen said, the SFAR provides an appendix, an alternative pathway for aircraft with a single set of flight controls. And the FAA was giving themselves flexibility there as well to consider alternatives to that appendix, alternatives to this is one way but not the only way. So as Kristen mentioned, there's a third authority within the SFAR to provide deviations to account for technologies or things that the FAA themselves maybe weren't able to consider during the rulemaking. And this is a point of nuance that I think that anyone who's trying to understand this topic should always have front of mind. While the SFAR was a massive achievement by the FAA, the Administrative Procedures Act restricted how the FAA could interact with industry while the rulemaking was ongoing. And especially because it was an expedited rulemaking, moving through the ex parte legal processes to do direct consultation with industry would have been very burdensome, and it would have impacted the time to deploy the rule itself. So as a result, the rule may not capture all of the unique capabilities of all the different types of aircraft that are coming to the fore, but it gives the FAA themselves the flexibility to make adjustments with what is acceptable in terms of qualifying a pilot. I'm going to talk about one of the big differences, actually, that Joby has been contemplating between the SFAR as published with the Appendix A pathway and what we would be pursuing with our pilot qualification program. The biggest difference is what's known as stage progression. So what we've learned as educators of professional pilots, is that self-efficacy, that belief that you are capable, that you can take on this task, it's exciting and meaningful to you, is something that needs to be imparted in a training program early and as early as possible. And the unique advantage of having such a highly augmented aircraft is that we can feel really confident and really safe that after the first 2 weeks of motor skills training and development, for example, in the VRs, which are not FSTDs and not qualified devices, but then the use of the full FSTDs in week 3, we're able to solo endorse and qualify a pilot for some of the simplest maneuvers very early on in the training program. Imagine an aircraft for a second that is only capable of going straight up and straight down. And there's one command that you can make to that aircraft: pull up, push forward, go down. That's it. Everything else is managed by the aircraft. Now, do you think that I could train you on how to do that and that you would feel confident in doing this? I'm sure that you would all say, yes, of course, I can do that. That's what we're trying to do very early on with the Joby pilot training program. We will just start with hover work. Pick the aircraft up, put the aircraft down. Now, the secret of what's going on in that lesson, though, is not seeing that you're capable of picking the aircraft up and putting it down. It's observing you as a pilot and your professional demeanor going through the pre-flight checks. Are you confident, for example, in powering up the aircraft, doing the pre-flight checklist, going through all the systems, monitoring for CAS messages? There's a lot of subtlety that we're actually looking for in that stage check. Why is this a difference from the SFAR as proposed? The Appendix A of the SFAR that defines one acceptable training pathway for single set of control aircrafts requires that the pilot complete all of their training, the complete full envelope, all emergency procedures, everything that you would have to do in the aircraft in the simulator first, then go on demonstration flights with an instructor, then begin to do actual in-aircraft operations. And so this slight tweak, this little modification that we're going to be proposing is, let's actually, instead of doing everything in the simulator and then finally at the very end getting them into the aircraft, let's progressively move the candidate pilot through different modules, right? The hover work, visual close patterns, full envelope, emergency procedures, each of those being stages through the training program. Now, we would not send up a pilot with a solo endorsement if they didn't understand all of the aspects of the Joby aircraft and how to manage it. That's why there would be 2 weeks of knowledge and skills work well before getting into the aircraft, plus the simulator time before your first solo endorsement. And we will be validating essentially this proposed pathway through the Flight Standardization Board process, which the Aircraft Evaluation Division will run to establish the type rating, as is typical with any aircraft. So just a other thing to kind of keep in mind here, we are constantly exercising our training program. We've had the opportunity to train lots of pilots, both from the DoD. There's Wayne Ringelberg from NASA. He's the chief pilot at the Armstrong Flight Research Center. We've also qualified DoD pilots for the remote operation of our aircraft as well. We've had 4 pilots operate the aircraft in a remote way that we do for flight testing, following the completion of the Joby training course that we provide for our flight test pilots using our engineering equipment, our engineering simulation tools. And we have been flying inhabited. And I think that more than anything, this is a proof point that the aircraft and the simulation capability that we have today, which is not necessarily a level 7 or a level C simulator, is capable of producing a safe environment for pilots to exercise the capabilities of this aircraft. I think that one of the most profound things I saw at this conference this week was a presentation by Willie, who spoke to his experience flying the Pivotal aircraft. And we were talking about it at lunch, and it was remarkable to see how straightforward I think that your experience was. You were using a simulation tool that was not a level 7 or a level C device. And through that very specific training program, you were able to get into a single pilot, highly augmented, powered lift aircraft and operate it confidently. And I think that when I look at where that aircraft is on the safety continuum, obviously you don't need a pilot certificate, it's not type certificated, the simulators are not qualified, but it's still something that dozens of pilots have already operated and exercised safely. And then you look at where the SFAR is, where we have something that is requiring very expensive $1 million devices and a very prescriptive, at least at this time, approach to training pilots. There is some bridge in the middle. We can acknowledge that there's probably some space in between that is also safe and also suitable to qualify pilots. We're excited to be building data sets through actual operations with our flight test pilots today, and we look forward to having FSB pilots operate the aircraft in the near future. But I think one of the things this industry is going to be pushing on a little bit with highly augmented aircraft is, what more can we do without necessarily requiring the full flight simulation training devices that have been required, or at least proposed, by the final rule of the SFAR today. So thank you for your time, and I think that I might have gone over. David, do I have any time for questions? We have time for questions? Great, thank you.
So I'm trying to take Willie's place in terms of questions. When it comes to sort of environmental conditions or the urban canyons or the different kind of operating environments that these aircraft will fly in, how will you, and at what point in the training program will you provide that kind of additional operational knowledge beyond the base level, where you're going to get into winds or urban or different kinds of scenarios, whether it's rooftop or what have you?
What you're talking about there is essentially supervised operating experience let's maybe use a different term since SOE is a regulatory term. Let's call it probationary flying that our Part 135 pilots in market will experience with mentor pilots. So just because you've received your type rating in the Joby aircraft won't mean that we're going to release you immediately to go fly revenue service missions in the markets you intend to operate in. We're going to want to be doing a lot of scenario-based training specific to the operating environments where these pilots will be day to day. I think, for example, we've talked a lot about the downtown Manhattan heliport this week. Alon provided a great presentation on that. That's a very unique operating environment. And the folks who fly there today it's a very small group of folks who are very familiar with each other. And building actual experience with a mentor pilot in that market is going to be critical before you're actually in commercial revenue service as a pilot. So there is a provision for that, but that is not necessarily a direct function of the SFAR.
Hi, Devin Boyle, NASA Glenn Research Center. Maybe I should bombard you with my numerous questions at lunch, but I'll start with one or two. One, does this pilot certificate exist only at the commercial pilot level? And then the second one is, given the fly-by wire nature of this aircraft, what is the emphasis in the ACS on degraded states?
So there's two really good questions there. The first related to the commercial pilot certificate. Today, the SFAR only provides a conversion pathway for commercial airplane pilots or commercial rotorcraft pilots. So 250 hours for your commercial rating, but 500 if you wanted to operate in air taxi service through a single set of control powered lift aircraft. There is a PPL pathway that is part of the unchanged Part 61 pilot qualification requirements for powered lift. There is no relief, there is no alternative pathway for an aircraft with a single set of controls. So there is a gap that exists between, for example, what Pivotal is able to do today with their ultralight and what Joby will be able to do with its aircraft. So private pilots will not be able to convert to the Joby aircraft. You'll need to be a commercial pilot. Over time, though, right, as we collect data, we'll perhaps be able to inform future modifications to the SFAR. The SFAR is meant to be a temporary rulemaking. It's meant to be revised and informed by data. And so I think that there will be an option in the future. The second question was related to the ACS and degraded performance of the aircraft. The ACS is a set of requirements for checking, right? Not necessarily training. It's important to kind of distinguish between the two. And what's really great about the ACS is that you can find certain maneuvers and procedures to be not applicable to a particular aircraft, and that's established through the FSB report. You can also have what's known as special flight characteristics or specific flight characteristics. There's an S in there. That are particular requirements that are in addition to the baseline ACS that must be completed as a part of checking. So it's a very flexible document. That's what I would tell anyone who looks at the ACS. The ACS is a starting point, but you can remove things that are not applicable. You can add things that are necessary.
Hey, Ryan, that's a sort of a good lead-in to the question I have. The ACS really doesn't talk about the power plant and how you fly, electric versus flying conventional. Flying conventional, you just have a little gas gauge to look at. Flying electric, you've got to think about capacity, voltage, you've got to think about temperature, a whole lot of things that the battery management system sort of works with you, but what knowledge, skills, and abilities are you having to train into pilots flying electric versus conventional?
Well, I mean, I think that this is where the FAA got it right, that all of these aircraft are going to have unique nuances to them, whether they're a turbine AW609 or a electric Joby aircraft. This is maybe one of those areas that I think industry kind of balked at the category, right? What's the purpose of a category if the fundamental theory of flight and operation of the aircraft is so distinct? We'll check that box in 10 years. We'll come back to that. But yeah, I mean, the Joby program, as a type-specific program, will train and check you on the specific mission displays and procedures relating to, for example, knowing whether or not you have sufficient hover time with a critical loss of energy at an approach decision point. So as a pilot, I'm going to want to know, can I hover for 1.5 minutes or 2 minutes following the loss of a battery in that critical thrust-borne landing stage of flight at a low state of charge? I'm going to be having particular indications for that pilot to confirm, whether or not that's an operation that is in the safe envelope of the aircraft, or should they continue and divert to a semi-thrust-borne or wing-borne landing because the power requirements for those types of operations are so much lower than thrust-borne flight. You have a lot more margin to do more with the aircraft if you continue semi-thrust-borne or wing-borne. So I think what you're hitting on is this aircraft is going to be really different. It's going to be really unique, and we're going to need to train and check for it. And I think that that's going to be what you'll see in the FSB report for this aircraft, are those requirements for checking in the type rating. I know that might have been like a dodgy answer. I think that what we'll have to do is do another session on the mission displays for the Joby aircraft, because I know that there's going to be a Verticon seminar. Actually, Alana's here. We're teaching a class together, Kristen, myself, and Alan. It's called essentially eVTOL for helicopter pilots, and that is going to be a module in that seminar. And so if you want more information, I encourage you to sign up, come a day early, and we'll do our first, I guess, public deep dive on some of these questions.
Thanks for my question. So from my understanding, Joby plans to operate the aircraft kind of as a, Part 135 operator. So what's the process if, can any commercial pilot show up at your door in Marina and say, I want to fly this? They'll be hired by Joby. They'll then be a Joby employee operating within a Part 135 environment. Or would that be sponsored from an airline? Or what does that look like? And what type of pilots are you looking for?
Yeah, that's a great question. So the type of operations that Joby is contemplating for its go-to-market will be only Joby pilots. So Joby Part 135 operations, either air taxi or air tour, all under the same certificate. We are not providing pilot training to folks who are not going to be operating for the airline at the go-to-market stage when we have a limited number of aircraft. We certainly would accept pilots who have previous experience and don't need to go from 0 flight time to the commercial certificate and then convert. If you have the prerequisites, if you have the airplane commercial pilot certificate with 500 hours and airplane instrument rating, and the aptitude for the Joby program, we would certainly accept you.
Quick question on workforce planning. You mentioned that you need to be a commercial pilot to qualify. How do you motivate commercial pilots to make the investment time and effort in learning your platform when one would assume there is a probability at some point that they may become autonomous aircraft?
Yeah, great question. I think that not to disparage the pathway to autonomy, but it's a lot harder than I think people give it credit for, and the team at Wisk is doing a ton of great work to enable it. But that is not an easy road, and it will probably be. I want to hear from Tom what he thinks. Let me just put it that way. I'm not a pilot, but as David said in my bio, I really want to be. Like, really badly. And I'm sure anyone else who didn't raise their hand before when David asked, are you a pilot? The people who had their hands down probably wanted to put them up. This aircraft is really cool. I mean, it's really fun. I got to fly the simulator all the time in the DC office and in California. NASA actually gave me a call sign because I did so much simulator work with them, so that's really cool. Zombie, if anyone's asking. I was really tired. I don't think that we'll have any trouble recruiting folks to operate this aircraft. I also, one of the really fun things about taking the mock-up on the road over the last year, especially at NBAA base, we had a lot of pilots who wanted to be the first, right? We're desperate to be like, take my phone number, take my card, take my email. When can I sign up? So my perspective is pretty bullish right now on the ability to recruit pilots. I think folks who are also looking at getting to 1,500 hours are always looking for really meaningful ways to do that. And I think that operating this aircraft from 500 to 1,500 hours on your career progression is a really great way to become, you know, whatever it is you want to do in aviation. And so I'm very bullish. Just one last thing too, you know, I mean, Joby's whole philosophy with this aircraft is to minimize the change, right? I mean, if I could call this an electric helicopter, I would. Or an electric airplane, more accurately. And so I think that all of that experience as a professional pilot in this aircraft will be directly relevant to whatever someone wants to do in the future, if they want to be a career pilot. All right, thanks so much.
And great questions, great conversation. Thought that was really excellent there in that exchange. So congrats also on the Part 141 flight school to Joby. And I really thought that was an interesting illustration of the bias that Joby's considering as it relates to helicopter and airplane pilots and the training that Joby's planning to have to provide related to muscle memory and how those pilots react to certain inputs. So really interesting stuff. That last question was a great segue into our next speaker, Tom Gunnarson, and we're really putting it all together here today. So Kristen set the stage, you know, laid the foundation as it relates to, okay, how we're going to certificate powered lift pilots in general. And then Ryan went a level down and zoomed in on, okay, well, we have a single pilot, single station aircraft. What does that look like? How do we train these pilots? And it's all related. And then Tom, you know, he's got that next. He's looking around the corner, and he's got that next challenge that Ryan highlighted, and that's okay. Well, what do we need now to certificate remote pilots? And our next speaker, Tom Gunnarson, is leading the way in that conversation around automation and advanced air mobility. Tom is the lead of regulatory affairs for Wisk Aero. Wisk is a Boeing subsidiary developing a remotely supervised all-electric air taxi and commercial service. Before coming to Wisk, Tom was with the FAA Advanced Technology Branch working on the development of consensus-based safety standards for small aircraft. And while there, he coordinated an FAA regulatory feasibility study on electric propulsion. So let's give a warm welcome to Tom Gunnarson from Wisk.
So at Wisk, our mission is to deliver safe, everyday flight for everyone. Safety is always first. We'll have the highest possible safety standard, autonomous flight with human oversight, very simplified design and no single point of failure. To describe what we're intending to do, we've put together a concept of operation that we've published, which is consistent with a similar one that FAA also put out. That's on our website. You can go and read it. There's a short version, which you can read really fast, or if you're having trouble sleeping, you can read the long one. We have a video here, if we can cue it up.
Here's how our self-flying system works from the perspective of the aircraft, the multi-vehicle supervisor, and the passenger. Safe autonomous flight starts on the ground. Like all aircraft operations, we must ensure the air taxi is safe for flight before we take off. Unlike others, our aircraft autonomously performs the pre-flight inspection. Prior to flight and continuously throughout the flight, the autonomous system checks and monitors multiple aspects of the aircraft, from power, avionics, controls, motors, sensors, seatbelts, and more. Inside the cabin, passengers prepare for flight. Safety briefings and instructions are provided via individual interactive displays, similar to those that you would expect to see on today's commercial airliners. This ensures the aircraft is ready for flight and passengers are informed and ready to take off. A critical component of autonomous flight is the multi-vehicle supervisor, who continuously monitors flights from our ground control station. Once the autonomous system has verified the aircraft and passengers are safe and ready, the supervisor is notified. As the final authority in the pre-flight process, the supervisor confirms the flight with air traffic control and initiates takeoff with a click of a button. In flight, the aircraft leverages proven existing technologies, like those used by commercial airliners. Through these enhanced capabilities, the aircraft can navigate, identify ground and airborne hazards, and adjust its flight path to maintain safe operation. Inside the cabin, passengers view their flight path in real time, allowing them to anticipate turns, climbs, descents, and transitions. The display also confirms the aircraft has recognized potential hazards and is taking corrective action. Real-time communication ensures passengers are informed throughout their flight. In our ground control station, the multi-vehicle supervisor continues to monitor the aircraft and the flight. If the aircraft takes steps to avoid potential hazards, the multi-vehicle supervisor is notified and may need to communicate the maneuver to air traffic control. For landing, the aircraft uses a combination of inputs from robust and redundant landing capabilities, such as precision navigation and onboard and ground-based sensors, to approach the landing area. The aircraft automatically confirms the landing zone is clear and begins its final descent to land. At the same time, cabin lighting, audio cues, and the interactive display notify passengers to prepare for landing. The multi-vehicle supervisor is made aware that the aircraft has started its approach and coordinates final clearances with ATC and the Vertiport. Meanwhile, the autonomous system is also relaying information like the health of the aircraft, passenger arrival needs, charging status, and more. This combination of proven technology, proprietary software, and human oversight is making safe, self-flying, all-electric flight a reality. For more in-depth information on our 6th-generation aircraft or our self-flying system, visit our website.
So when we look at our certification pathway, there are 4 general areas. I'll focus on 2 that I think are relevant to the discussion. One is on the ground systems, the development of new pilot supervisor approvals and alternative path to Part 61. So you can see from that video that we don't have what we would consider pilots. We don't have people in the cockpit who are doing any sort of control of the aircraft. So it's a very different paradigm when it comes to then how do we qualify and train people. And then on the commercial operations side, develop crew qualification requirements for Part 61. What does that look like when we have a Part 135 operating certificate? And as we go forward, we're doing this in a crawl, walk, run approach. Then we need to be able to add this autonomous system to our 135 certificate. So that's what it looks like. I had the opportunity a couple days ago to, for the first time, take a Waymo ride. I'd been kind of curious about that. I'm based in the San Francisco area, and we've got a lot of them, and it seems like there are a lot of them around here. And my coworker said, "Oh yeah, I use them all the time," and he said, "Let's go do it." So he did all the work. I get to just kind of watch and then get that experience. So of course my head is with our aircraft, and I'm thinking, well, you know, how do these compare? And the experience was very pleasant. I had no qualms. We were only in the city. We never went more than 15 miles an hour. So I wasn't concerned from a safety standpoint anyway. But I thought, you know, if that's what people get used to now, this is going to translate really easily, I think. So all of our activity, when we talk about the people involved, is on the ground. So we have different positions for people who be part of of the team who are operating the aircraft. So here you can see a few of them and what it would look like in a operating center. Here's basically the diagram from start to finish. If someone were to want to use this mode of transportation, they get out their smartphone just like you do now with an Uber or a Waymo. And that information would go to our Fleet Operations Center where that team is and go all the way through the process of having the aircraft fly to its destination and all of the little pieces that need to be in place for that to work. So when we look at this from the standpoint of our first two speakers, so how do you train and qualify the people who are involved if they're relatively unconventional to what we're used to today? Well, some things are still going to apply. We're not expecting to have a completely new system than what FAA has today. We want to integrate the components of that. So when we think about certification elements, aeronautical knowledge, aeronautical decision-making, flight proficiency, it might be a little hard to do the flight proficiency part unless you can fly your chair. But the other two certainly apply. And the other part is that we're sharing functions when you think about traditionally what a pilot does. Well, a lot of those are actually going to be given to the aircraft to do. So when we look at aviate, navigate, communicate, that's going to be split to some degree. The higher level functions where you really want to have a person involved will stay there. So if things come up that are outside the norm, that's when you might have some human intervention. And then again, when we think about crawl, walk, run, there's going to be more put on the person initially. So for instance, communication with ATC. You know, we've got a traditional system, how that works. We're not going to change that. But over time, and as we get experience and the technology continues to advance, there may be other ways to do that in the future, but we won't start there. So how do we envision this process taking place to be able to qualify the people who are going to be on the ground in a remote site? So training through scenario-based education and simulation. We've already talked about some of the things that are in place today, to having a full access simulator when you're just sitting in a chair the whole time probably doesn't line up very well. What we heard earlier about the VR experience might have some aspects that would work for us, but actually we already have these ground control stations that have a lot of this equipment. In fact, we have a whole, what we call an autonomy lab that looks a lot like the picture you saw earlier, where we have people in positions where we're already doing simulated flights, and all of the operations that we expect people to do are being evaluated, and that will be the basis for our training programs as we go forward. And then on the testing side, knowledge and decision-making are the primary components, again, because we're not in the aircraft, and there's no direct connect between how the aircraft flies and a person on the ground. So what we've heard earlier with the SFAR and with the components that are out there, plus what's coming, I think when we think about remote operations, we do have a rulemaking that's working its way through, hopefully sooner than later, for BVLOS in Part 108. There's a lot of concepts in there for the UAS community that should be applicable to us. We'll have to look at it from the standpoint of scaling, and if we look at the rigor when it comes to the levels of safety, you know, where are we going to hit on that, and then what would be appropriate, we'll see. But these are all really good seeds for us to then be able to know a little bit, at least, on what the expectations are, and then how we can help facilitate what makes the most sense to get people to a level of qualification that FAA is comfortable with. So just really quickly, since we know who the next speaker is going to be, I'm going to touch just a little bit on infrastructure, mainly because, again, when you think about our operation compared to a piloted operation, it's different, especially when you're coming into a landing site. You still have to do all the same things, but they're going to, you have an aircraft that is going to have to do a lot of that work. We'll have people on the ground who will share in that workload, but it's not in the traditional sense. So just really quickly, when we look at some of the considerations, so this talks a little bit about the baseline siting and design considerations for vertiports from our perspective. So this is what we're talking about in terms of the aircraft. So 4 seats, 50-foot wingspan, quick charge, 15 minutes, max takeoff weight, 7,000 pounds. We're on skids. There are carry-on and personal items, and we're going to operate under instrument flight procedures, no onboard pilot, supervised autonomy. So if you put all those together, what does that mean in terms of what the impact is on a landing facility? So, yeah, I know you can't read all that stuff. That's okay, but the point is there's a lot of things to consider for us. So I'll just hit the top here for siting considerations, sizing considerations, terminal considerations, electrical, communications, operational. Those are all things that we see with a little different lens, but this is all within the scope of wanting to integrate. So I don't think anybody would want to have the industry have to go out and make multiple versions of basically the same thing, but for different operations. The idea is that we can all share. We think that what we'll bring to the table are a lot of functions that will be safety enhancing and will actually enhance what traditional operators are able to do today. Maybe take off some workload. I think that's enough for me. I just ran out of time. So I don't know if we want to have any questions or.
Tom, I know I could just ask you on the side, but now I really want to know this moment. You said on that last slide, GPS might be required for infrastructure. I'm sure that there's lots of other systems for navigation. Obviously, GPS interference is something that lots of folks in aviation are dealing with today. The aircraft doesn't need GPS in order to operate, right? Probably.
Yeah, so there's what's in writing and then what everybody talks about every day. This is all pretty fluid. So I can't directly answer that question, sure. Mainly because I'm not the one who put that together. But also, we'll take advantage of any technology that's going to help get the job done. And I think in most cases, it's not just one thing.
Right.
That it's actually a combination. And from a safety perspective, you want that anyway.
Right.
So that's a semi-answer.
Can I ask one last thing?
Of course.
The communicate definitely feels like that's on the remote supervisor, aviate on the aircraft. Where does navigate fall? Is it both or principally aircraft?
Principally aircraft. And the reason for that is that, thanks for the questions. Best case scenario is all of this has been punched in and approved both from the operator and those who are controlling the airspace ahead of time. So to have the aircraft perform all the navigation functions on a defined route makes sense. The other is that there's only so much you can do from the ground if you do not have pilot controls. We have, I mean, you saw there's just a table with basically a computer monitor. So we don't want to get in a situation where that human-machine interface is like in question as to who does what. So that's part of that as well.
On the passenger experience side, on the video, it mentioned that there's direct real-time communications. Is that envisioning that the passengers at any time can communicate with the supervisor? And then secondly, on the customer research that I'm sure that you're doing at this point, can you talk a little bit about some of the elements that are rising to the top as far as concerns or what it would take for early adopters to become passengers in the beginning?
Sure. First question's easy. Just like on my Waymo ride, there's a button. And if you want to talk to somebody, you can. Of course, all the flights will be monitored. May or may not be real time because of all the possible things that could come up. But generally speaking, it's like an on-demand sort of service. If there's some perceived need, there's the opportunity to talk. Otherwise, the flight could be completely quiet the whole way. Other than there's a monitor that shows the flight itself as it's happening, so everybody can know from a situational awareness standpoint where the aircraft is going, where is it during the flight, things that you'd want to know as a passenger, but otherwise no direct active communication. Willie?
Yeah, just one question, autonomous versus remotely piloted, because what's happening when you fly with the aircraft is still perfectly fine, but suddenly all communications channels which the aircraft has with the ground are gone. With a normal aircraft, with a piloted aircraft, you still would have the pilot. He could fly to anywhere he wants. He finds an emergency landing field. He would put it down here. The remote pilot cannot do this. In this case, would then the aircraft have the automated capability to act like an autonomous flying aircraft for the emergency case?
Absolutely. So, like I was saying before, everything is pre-set up. That includes the route of the flight and emergency landing areas along the way. So at any given point, depending on what the situation is, the aircraft will essentially make a decision if something like that were to happen where all communication was cut off. But quite frankly, there's not going to be a lot of communication during the flight anyway between the ground station and the aircraft because it's all predetermined. But if something did come up, yeah, it's definitely, contingency planning is a big part of that.
Yeah,
Last question.
It's Harold Chorholm from NSS. Have you thought about adding, since we've been talking, a lot of people have been talking about AI here, are you on the ground, the multi-vehicle supervisor, have you thought about adding AI to either that or to navigation on board or to, uncooperative traffic detection?
Someday. So again, I'll come back to the crawl, walk, run mentality here. We want to keep it as simple as possible. And also, we want to make sure whatever we're going to incorporate is proven. And that's still a long road ahead. We're just kind of starting into that arena. So that might be a little bit much to take on when we want to get to entry into service. But as time goes on, I can't imagine it not being incorporated to some degree. Thank you.
All right, appreciate it, Tom. Interesting parallels with your Waymo experience and what it might potentially look like related to autonomy in aviation. So in the spirit of keeping with our theme of putting it all together, where are these aircraft going to take off and land? A lot of you might say, well, airports and helipads, and a lot of the manufacturers would love to just agree with you and we wish it were that easy. But there is due process in ensuring and maintaining safety in the aviation system. And I've had the privilege of working with Robert Bassey for the past 5 years, both in my time at the FAA and now in industry. Robert is one of the leading voices from the FAA Office of Airports when it comes to advanced air mobility infrastructure. Robert has nearly 2 decades of experience in aviation infrastructure as the lead engineer for Vertiport design at the FAA Airport Engineering Division. He works to create safe, efficient, and scalable vertiport design standards for eVTOL aircraft. He also oversees development of heliport design standards and various other airport engineering standards. So let's welcome Robert to the stage. Robert?
So I'll be remiss if I don't mention that, it's generally a touch and go time within the FAA and the broader federal workforce. But I'm glad we were able to make it here, and I think I'm holding down the fort for the FAA. So, but as David mentioned, my goal today is to focus more on the ground infrastructure, right? Where are these aircraft going to land and where they're going to take off from, and speak to frankly, some of the changes that went into the most recent publication of design guidance, which is our engineering brief 105 alpha, and also try to forecast where we're going next in terms of standards development. As part of the bargain to be able to make this trip, I'll have to say this as well. There's some restrictions put on what I can say, so we'll manage to do this accordingly. All right, so what were the major changes that went into our most recently published engineering brief? In the interest of time, there were myriad changes, but I'm going to just highlight just what I think are the major ones. So, right, the first has to do with essentially how do we classify a vertiport. Heliport Design Guide, which is the analog for that's been used in terms of how we develop vertiport design standards for a while, has essentially up to this point 3 types of heliports: your general aviation, your transport, and your hospital heliport. They all have different applications in terms of intended use and operational purpose, and that's what drives the different types, essentially. The one change that was made was to now essentially classify a vertiport as the 4th type of heliport. So in summary, you will have a GA heliport, which essentially caters to individuals, businesses that are using it for private or non-commercial operations, infrequent landings, those sorts of use cases. You have a transport heliport, which is used primarily for larger scope operations, commercial operations, air taxis, air shuttles. Just also worth mentioning that the transport heliport did serve as the baseline for our initial set of vertiport design standards that went into the original version of our engineering brief 105. You also have the hospital heliport. The name says it all. It helps to serve hospital facilities, EMS operations, has some specialized design elements as a result. Then you have your vertiport, which in our minds is that type of heliport that is optimized to cater to aircraft with 3 or more propulsors, so power lift aircraft, special class rotorcraft, and as a result, there's some unique design elements that will be applied as well. One upshot and benefit of this change has to do with how the states would manage this, right? That states are grappling with how do we classify vertiports. As a result of this change, states now can continue to classify vertiports as a type of heliport, continue to leverage existing regulations that they're already familiar with, rather than trying to figure out, how do we create new regulations and standards at the state level to accommodate these new types of infrastructure. Okay, this kind of addresses what I just went over. One other thing that served as helping to drive this rationale has to do with the SFAR that was recently published and the definition of a heliport in the SFAR. We feel that this change brings the definition of the heliport in the SFAR in alignment with what's in our design guidance, right? And as already touched on the implementation of the state level and the benefits of that. Concurrent to this change, we also made an update to the identification marking that was used as the symbology for a vertiport. Up to this most recent publication, the broken wheel symbol was employed as the identification marking for a vertiport. We did a research effort under the auspices of our technical center that involved working with pilots varying ratings, different experience levels, doing a human-in-the-loop simulation at one of our facilities at Tech Center, and using some VR simulators. And they tried to look at different symbology. They looked at the broken wheel. They looked at what EASA has proposed as the symbology for vertiport, which is the V, and they juxtaposed that against the heliport H identification marking. The pilot feedback that was received, essentially, let me speak a little bit to what the process looked like. The pilots were obviously in a simulator. They were not looking at replays. They were actually flying these approaches in the simulator. We had about 33 runs conducted with about 18 different pilots. The runs, which are about 3 minutes for each one, and they started about 3 nautical miles out. And anyway, based on all of that, kind of research scope, the outcome essentially showed no significant difference based on pilot feedback in identifying the vertiport and controlling the direction of approach to the vertiport in terms of the broken wheel and the heliport H symbol. There was also the added benefit of pilots already having familiarity with the heliport H, given that it's already been established part of aviation infrastructure over the last several decades. As a result of these changes, and also to further, bolster the alignments between vertiports and heliport infrastructure, we've now updated that marking in our heliport, in our vertiport design guide to the H from the broken wheel. We also added a VTOL marking, as you can see it there on the screen, and that's placed alongside the H on the teal-off, and that is intended to designate these facilities as uniquely catering to aircraft with 3 or more propulsors. That identification marking that's placed alongside the H leverages a precedent that was set by the use of the PVT marking in a heliport design guide, which the PVT marking essentially was used to designate certain facilities, certain heliport facilities as private use only or privately owned. So once again, we're leveraging that precedent in terms of the size and the positioning of that marking, but the goal of adding this marking to the identification system is to, once again, designate these facilities as having a unique set of requirements tied to a vertiport, even though it is indeed a heliport. So one way of thinking about this is all vertiports are heliports, but not all heliports are vertiports. One other major change had to do with the introduction of a downwash caution area. What drove this was the potential that we identified, frankly, for the downwash and outwash produced by these aircraft to be dangerous in certain cases to people, property, structures on the ground. So we wanted to assess that. So we conducted a downwash, outwash test that consisted of essentially six departures and approaches from 6 different headings, 2 different hover heights. And the idea was to fly a full transition from takeoff to landing for each of these aircraft. We worked with several of the OEMs to conduct this test. And the upshot of the test, frankly, showed that even though different aircraft had unique downwash footprints, when we juxtaposed the maximum velocities, right, and direction of the downwash, outwash, and also when we looked at when and where the downwash, outwash for these aircraft exceeded the safety area, and now we compared that against what we include in our heliport design guide, which is a national weather Beaufort scale, which tries to identify velocities based on jet blast and propeller wash that could increase a safety risk, and settling on 35 miles per hour as that sensitivity threshold within that scale. And the reason we settled on that was driven by the fact that these vertiport landing areas are located close to aircraft parking positions. Also understanding the potential for these downwash, outwash to create, surface ground erosion, FOD, wake recirculation, those types of issues. We established that based on the peak velocities that were measured and observed for the aircraft that we tested, there would need to be some sort of operational area that is included within our design standard to protect people and property on the ground. And we're calling that operational area essentially a downwash caution area. It is not a physical area. It is established in the form of a boundary, right? That where the movement of people will be restricted in the event that there are operations of aircraft that could potentially produce a downwash outwash that would exceed that threshold, that 35 mile per hour threshold. Concurrent to the publication of the engineering brief update, we also published a technical report that detailed example distances for what that downwash caution area would be based on aircraft type, for aircraft 7,000 pounds or less. And we also included a stipulation that for heavier aircraft over 7,000 pounds, work directly with us to identify what those appropriate distances need to be. Now, it's important to mention that guidance right now is very initial guidance, right? We continue to work with OEMs to collect more data, to iterate on that guidance, right? And so expect that guidance to be frequently updated as more data comes online. Lastly, major change has been in terms of the direction we're going in terms of design standard development. Up to this point, the goal, and people have heard me brief this out in prior meetings, has we've always been, engineering brief, iterate on engineering brief, transition to advisory circular by 2025. That's kind of been the pathway. But we try to be responsive to industry feedback, right? So there's been a lot of momentum building within the industry for a unified vertical lift infrastructure design document. At the same time, we had a FAA reauthorization bill that was passed last year, and that particularly pointed in the direction of unified guidance and instructed us to go in a performance-based direction in terms of our design standards. So in response to all these factors, we are pivoting, frankly, towards the publication of a unified vertical lift infrastructure advisory circular that would now include heliport and the vertiport design in one guidance document. So that's the goal. And we intend to do this over the next couple of years. Right, this approach we think leverages commonalities between heliport and vertiport design because we're going to try to accommodate the unique needs of each sector. So what are the commonalities? Operational similarities. Both of these aircraft take off and land vertically, so they may need similar spatial requirements. There's similarities in the flight characteristics. Both of these aircraft operate in confined spaces, urban environments, rooftops. May have similar operational envelopes in some cases, and all of those similarities we would need to find some common ground in terms of design elements as appropriate. But there are some differences, right? Differences in size, differences in the propulsion methods or propulsion types. Right, energy requirements, right, the charging infrastructure, and then there are other differences in terms of flight characteristics that we're also observing. So we're going to try to, account for those differences as well within our design standards. So this is not a trivial task. We're going to have to conduct operational testing with all types of vertical lift aircraft that we can get our hands on over the next 12 months. Right, and that's one of the big themes I want to get across today is that we need to work with the OEMs to collect as much data as possible. And when I say OEMs, I mean both eVTOL aircraft OEMs and helicopter OEMs alike over the next 12 months for us to get to that vertical lift infrastructure AC over the next 2 years, right? So our research team is going to be conducting field testing to further research and consider the effects of these aircraft operations as they interact with the ground infrastructure. The field testing we're focusing right now mainly is going to focus on the downwash, outwash. I already spoke to that earlier. The landing accuracy on how precisely do these aircraft land on the ground relative to the center of the tail-off, right? Related to this, we've also entered into an agreement with our aircraft certification service that we're going to develop performance targets, both vertical and horizontal performance targets in terms of landing precision for these aircraft to meet that are aligned with helicopter landing precision targets, right? And those targets will be provided in the intervening period till we get to an advisory circular that would allow aircraft as part of their TC as an option, not mandatory. We don't want to impact the TC schedules for these aircraft, but as an option, if they're able to demonstrate landing precision that is equivalent or greater than helicopter landing precision per these targets, they will be able to use existing infrastructure today. So that's one stopgap that we're going to employ. But that said, we'll continue to do our field testing to get to that AC over the next couple of years. We're also going to look at autonomy and the impact of that in terms of ground infrastructure and some of the things that Tom already touched on, and how well do these aircraft maneuver on the ground. That's another aspect, because we need to come up with standards around taxiways and parking standards for these aircraft. So the downwash, outwash testing, again, we're going to deploy a variety of ground level and vertical wind sensors and place this strategically around a vertiport test environment and have these aircraft fly these full transition from takeoff and landing, and then collect the downwash, outwash velocities at different points, hover, takeoff, and landing, and try to capture at all these points. And then, once again, this is just our test setup for landing accuracy. We're measuring how precisely these aircraft land relative to the center of the tail-off, right? And also trying to collect some data around what is the turn radius and taxi maneuvers of these aircraft to inform sizing and separation of taxi lanes and parking. So here's our schedule. Once again, we're trying to get this done by the end of the calendar year. So I encourage all OEMs in the room to please, I understand that you have busy schedules and a lot of things being, you're tugging at and trying to sort through. But this is one important element to add to your timeline, because we need to get testing with the OEMs done by the end of the calendar year. And our goal, frankly, would be to do much of this by the end of August, right? So we have scheduled testing dates that are already underway with several OEMs right now, but we need to get more testing dates confirmed and testing campaigns confirmed on the schedule here shortly. So with that, in the interest of time, I'm going to kind of gloss over this slide. This just talks to our data-driven approach within the agency, the fact that as much as we are committed to getting to that unified performance-based or performance-informed advisory circular by, over the next 2 years, we are also committed to making updates to our engineering brief as needed, over that, in that intervening period, so we get to the advisory circular update and continue to, issue internal guidance and communications. And then the heliport design perspective is important to mention here. A heliport design guide, since it was established in the U.S. since 1959, has always been a prescriptive, I would say rigid, one-size-fits-all compliance-based standard. We are now trying to pivot that standard as part of this update to a performance-based standard that's going to be based on performance metrics for helicopters. Not a trivial task. The FAA has gone down this path before and has been unsuccessful. So we're going to need the collaboration of helicopter OEMs throughout this process, and that's the message I'm going to be driving home. I would say that so far in our outreach, we've had some success with some of the OEMs. We'll see how that continues to pan out, but the goal is to have this unified document not only focus on VTOL and power lift aircraft, but also on helicopters, and really reflect performance data for helicopters alongside those for power lift aircraft. And with that, I know I'm over time, so I don't know if you have time for questions, David. Okay.
Hi, Johnny Liu, Transformative Vertical Flight Working Group. The question about the possibility of all the efforts you guys put in, is there a way that you can envision to streamline, help enable emergency response use of unprepared locations for those purposes? Give example, the medical emergency response landing in the cul-de-sac of somebody's house area, or the leveraging the shopping mall parking lot for help support the wildfire deployment, or even after hurricane, we take a couple of high school football field as a temporary staging area. Do you see a path forward to streamline or enable those operations?
Absolutely. So I've focused a lot of the discussion here around the Vertiport concept. One of the things that we're looking to include in our update, or I would say our performance-based advisory circular, is different types of Vertiport, right? Or different classes in terms of infrastructure design of heliports. So the Vertistop concept, which I think is kind of where you're trying to get at, is something that we're looking to definitely incorporate in future guidance. That would be able to leverage facilities with less accompaniments and not as many, I would say, design elements, right, in terms of its infrastructure.
Hey, Robert, question on so the old, I don't know when it originally came out, 90s maybe, Vertiport AC had a provision for elongated FADOs, right? And one could envision, as Ryan was talking earlier, you've got some sort of degraded state where you can't quite do the vertical landing, but you could still do a really short one. And you've got aircraft like Electra, right, that are trying to do a super short takeoff and landing kind of capability. So has there been any discussion on, say, elongated FADOs or anything like that to be able to incorporate those sorts of aircraft moving forward into the same AC?
Great question. There's been quite a bit of discussion. I think where we are now as an agency is trying to figure out, when we think about these type of operations or STOL, right, operations, do we want to include them or incorporate them as part of this particular advisory circular, or do we want to have a standalone document that would address those type of operations? I think where we're leaning is the incorporation as part of this advisory circular. So you can expect to see facilities that would essentially cater to STOL operations uniquely as part of that update to come.
Hey, Robert, Peter Schmidt from Transcend. When are we going to talk about water-based vertiports and the dimensioning for those?
We haven't had much discussion around that. We have dozens of things we're trying to juggle and consider as we think through this. That's something that's definitely we've put a pin on to address in the future. I cannot guarantee you that we're going to address that as part of the initial iteration of the advisory circular, but definitely something that we'll address in the future for sure.
Again, great conversation there on the topic of vertiports and infrastructure. And, Mike, I don't know that I have 15 minutes to fill here, so we might be able to get to lunch a couple minutes early. But just like to take an opportunity to provide a recap and really hit home on some of the key elements of the discussion today. And there are three for me. One, regulatory clarity has arrived to a large degree. The SFAR represented a major milestone in defining the path forward for powered lift pilot certification, training, and operating rules. Collaboration, too, has been key in that. And then we're looking ahead to full integration. So, a couple key points for me, Mike. Kristen outlined, okay, this is what it's going to take to certificate your initial group of powered lift pilots. Are you commercial instrument rated airplane or helicopter pilot? Ryan made the point then that the SFAR, which provides that avenue, is transitory. The SFAR is in place for 10 years. So at the end of that 10 years, the agency is going to have had the opportunity to collect data and evaluate operations, and then formulate a final rule, a new Part 194 in the CFRs. And then I really like what Robert said there. It helped to kind of clarify some things, but all vertiports are heliports, but not all heliports are vertiports. And Robert, however we can help support you at GAMA in collecting that additional data you need over the course of this next year, want to offer our support there. So part of the cool part of my job is, for every 20 minutes of debrief that you saw here, there were hundreds of hours of technical discussions, roundtable discussions with authorities, and detailed comment development to NPRMs, or Notice of Proposed Rulemakings. And I think, just to celebrate the success, the process works. And between the initial revision, the NPRM of the SFAR, the initial revision of Robert's EB 105, and then the dialogue that followed between industry and the FAA on both of those pieces of rulemaking, and where we landed on both is really testament to that process, to the discussions we've had. And, if you use it and if you leverage the channels of communication that are available to you, you do really have an opportunity to influence the outcomes here. So just as a point of curiosity, Mike, as we kind of undertook a lot of this together over the past couple of years, were there any specific areas of, challenge that you thought, man, I just don't know if we're going to get past this, or I don't see the light at the end of the tunnel for this? And then, where we landed on those issues.
Yeah, thanks, David. And this is also going to be an opportunity for some information exchange. So, we have till the top of the hour. We don't need to go that far, but we have a few things we just wanted to really emphasize. And then, again, leave the opportunity for some more discussion, maybe some more broader issues. But I will say that many people, when they saw the draft SFAR, I think people called it like a Frankenstein document, where it's like everybody in the FAA got to put in their 2 cents, and it was just really not cohesive and contradictory to itself. And somebody who who's very wise said, we had always labored under the assumption that the FAA was really leaning forward to help support eVTOL. And maybe this SFAR really is what they're really thinking, that they really don't. They don't want AAM. So it was kind of a heart-stopping moment. I think it was August of 2023 when the draft SFAR came out, and it's like, oh my God, there's some real things in here that's going to make it. I got quoted in saying that it was a showstopper. Well, of course we can overcome these hurdles with enough time and money. But the difference, the FAA listened to the 99% unanimous chorus going back saying, these are the areas that need to be really, go back and do some more work on this. And the SFAR, it really came out, the final SFAR came out executable. There's a number of issues, some of them are highlighted here, where there's, again, there's some rough patches that need to be worked out that don't, there's some conflicts, there's some things that seem to be just too hard for not any safety benefits. So there's some improvements that can be made through clarifications or potentially waivers or deviations if necessary, but I won't say it's in the noise. There's still some important issues, but the FAA listened, and it is executable. There's a pathway to do some, and there's some things that maybe can be made more efficient. Also with the EB 105 and the draft 105A. There was a little bit, we had a very short timeline to make the congressional deadline of getting it out. With the leadership of GAMA, VAI, VFS, and other organizations involved, we really, I'll say we crashed. We put everybody together. We basically pulled all-nighters, for the 30 days that we had to do that, and it was really, really intense. And we were very pleased with how things came out in the final EB 105A. And again, with the focus group and other things to get more feedback, has really been, I think, transformative. So it's all execution from now on. And I do want to also say, so glad, Robert, that you're able to make it here. We had originally had several FAA and DOT speakers who were not able to make it due to the change in administration. So it really means a lot to us. And this dialogue that we've had today, but also for the last several months, last several years with the FAA is crucial for seeing these aircraft get into operational status. And so, events like this, venues like this, organizations like these are really critical to help focus and unify or get great consensus on the feedback for how to best move forward.
Yeah, agreed. And it's really appreciated your partnership too, Mike, over the past couple of years. So with that, are there any larger overarching questions for the group? I know we missed one when Kristen had been speaking. Sounded like there were a couple job inquiries for Ryan from the commercial pilots in the room. Going once, going twice. Okay, Mike, I appreciate it. Yep, thank you.